A plus B, I heard,
AB.
You gonna get it?
yields AB. Very good. So this is an example of a chemical equation.
Can you get this door
All right?
open?
And we talked about how last time on one side of this arrow,
Thank you, Sam.
these are called what?
Reactants.
Reactants. And this is called a product. That's right. Reactants and products. Now, we also said that amongst all the reactants, there should be the same number of A's as there are amongst all the products. Correct?
Yeah.
When you have that scenario where how many A's are on the left side? Do you guys know the difference between your left and your right?
Yeah.
This is L for left. This is R for your right. Okay? On the left side of the arrow, how many A's are there altogether? One. On the right side of the arrow, how many A's are there altogether? One. See the A? There it is. It's one A. On the left side of the B, on the table of the arrow, how many B's are there? One. And on the right side of the arrow, how many B's are there?
One.
That's right. So it's the same, correct? Now, if I went like this and said 2 A's combined with every B, right? And we had A2B. Does that make sense?
Yeah.
Is that now a balanced equation still?
Yeah.
How many A's do we have on the left side?
Two.
2. How many A's do we have on the right side?
2.
Okay, that little 2 right there says that means we have 2 A's. And how many B's do we have? 1. Okay? Now, what if I went like this? Let's change something up really quick.
They can see it.
Can they?
Yeah.
Sam.
Sam and Ben. I just see.
All right. What do you see there?
4A plus 2B. Yeah, but then the thing is wrong.
Yeah,
you have to put 4A, not 2A.
No, that's correct. 2 ABs. No. 4A.
And they equal.
How many A's are on the left side altogether?
2 ABs.
How many A's are on the left side altogether?
4.
4. Can everybody see that? 4 A's.
Oh, I get it.
All right.
be times.
4 A's. I have 4 A's there. How many B's on the left side altogether? 2 B's. Now, how many A's do I have on the right side altogether?
4.
There's 2, but there's 2 of what? What are there 2 of?
There's 2 of 2 A's.
There's 2 of this thing that looks like this. A to B. Right? Like this thing here. Whoops. A, 2 B's. Can you see the A? What color is A in this scenario?
Red.
Red. And then how many B's are there?
2.
2. And it says I have 2 of these things, right?
Wait, I think you said that backwards.
Did I really?
Yeah.
A, 2. So what's A in this one?
Oxygen.
No,
They keep
it's
saying
white,
red, it's white.
Right? Because there's 2 of them. What's B?
White.
Red. Can you see it? Because how many are there? How many B's are there for every one of these things in the box?
1, 2.
So it says, let me rewrite it a little bit clearer.
That rag should be behind you.
Nothing. I was going to have you find me a rag if I didn't have it. All right, so we got 4, what did we say, A's? Plus 2 B's, making 2 A to B. Okay? So this A to B right here, how many of those things are there?
2 A's.
There's 2
A's for
A to
every
B's.
2 A's and 2
And now if I draw this out, it looks like this. Right? B with 2 A's. Right? It looks like my molecule that I have here in my hand, right?
Yes.
But how many of them are there? There's 2. How do you know there's 2? Because it says there's a 2 in front there. So I'm going to draw 2 of them.
What
2
are
of
these
these
equations used for?
B to A's.
Chemistry. Stoichiometry.
Oh, good word. Stoichiometry.
All right, so here it is. Here it is, right? Now, let's look at, I'm going to draw a line like this because this side is one side of the arrow and this side is the other side. How many A's do we have over here, did we say? 4 A's. And how many B's? 2 B's. Now on the right side, can we see how many A's we have altogether?
4.
Can you count? Can you point your finger to all the A's for me? Stand up. and point your finger to all the A's. 1, 2, 3, 4. Very good. Just on that side, Emmett. Very good. Excellent. So there are a total of, and I'm going to write that over here, a total of 4 A's. And how many B's are on that left side, or on the right side there? 2 B's. Very good. Does that make sense? So, 2 B's. So this is a balanced equation. Does that make sense? All right? Now, generally, when you write a balanced equation, you don't need to have multiples of the different things. Because I can rewrite this as, like I did before, 2, and make this 1, and make this 1. And now it represents the same thing. The only difference is I'm only talking about one compound, right? Does that make sense? What, have an eraser?
I don't know. Wow, where'd you get an eraser from?
What happens if you do
Why you
times?
got an eraser?
Can you do times with those stuff? No.
Well, we are doing times in a way. Because for every one of these, there's 2 A's.
Thank you, Whitey.
So we're doing 1 times 2. All right. Now, I'm going to give you an equation. And you're going to have to change the stoichiometry. The stoichiometry are these numbers in front, right? Wait, what's the number here?
1.
1, right? We don't show it if it's just 1. And what's the number here? 1, right? I'm going to show you an equation, and you're going to... Oh yeah, I have an eraser. I'm going to show you the equation, and you're going to work with your neighbor and show me what numbers...
Wait, who's radio? But who's Tommy with?
Oh yeah, you're gonna be with me,
Okay, I have 3 arrows. See, arrow 1, 2, and 3, pointing to the stoichiometry of these different compounds. All right? Now you're going to try to find out what number goes here, what number goes here, and what number goes there with your neighbor. Okay, so talk to your neighbor and try to figure it out. You can know by counting up how many H's are on this side, how many O's are on this side, how many H's are on this side, and how many O's are on this side, and then trying to fix it so it works out.
Can you figure it out, Whitey?
How many H's are on the left side? 2. You see them? 2 H's. How many H's are on the right side? 2. Oh, those are fixed then. That's okay, right? How many oxygen on the left side? 2. 2. How many oxygen on the right side? 1. Oh, so that's a problem, huh? Which side needs more oxygen?
The right side.
The products side. So what can I do to give more oxygen here? Can I put a 2 down here?
No.
No, I can't. Because if I put a 2 down here, it means that it's a different thing. I'm making something different. And in this process, I want to make sure that I'm showing you, hey, if you take these and mix it and make that, right? I can't just change these numbers. I can't make this number a 1 or make this number a 1. Does that make sense? I can't change the numbers that are down below because those are describing how the molecule comes together. I can change the stoichiometry, the numbers in front, right? So what can I do to make sure I get, how many more oxygen do I need over here? I need 1 more. I need a 2 altogether. So what can I do to make it so I have 2 over there? Yeah.
Make there 2 H2s and 1.
Put a 2 right here first though, right?
Yeah.
Put a 2 right there.
And then 2 H2s.
Now, how many oxygens do I have on the left? 2. How many oxygens do I have on the right? 2. Is it balanced?
No.
It's not quite balanced, is it?
There's 4.
Now, how many hydrogens do I have on the left?
2.
2. And how many hydrogens do I have on the right?
4.
4.
Put a 2 in front of the H. Put a 2 in front
So
of
now I need a 2 here because I need 2 more hydrogens.
2 H2?
Now are we balanced?
Yes.
2 H2s come together with 2 and O2. How many O2s do we have?
1.
1. And we make what?
2 H2s.
2 H2Os. All right, so let's see if that makes sense. Okay? So here's 1 H2, right? There's the H2. How many of those do I need?
2.
I need a second one, correct? And then I need 2, or how many oxygens? O2, just one O2. So apparently, from these, I'm going to be able to make what?
H2O twice.
2 H2Os. So let's see, is that going to work?
Yes.
Whoops. Thank you. Let's see.
Keep Dana.
There's one H2O,
Marker.
correct? And the other one? I make another one, right?
Yeah.
Now, the number of bonds that I have can change, and often does. And you know what you call it when you take compounds and change how they're bonded together? You know what the word for that is? There's a fancy word. It's called chemistry. When you say chemistry, chemistry is the combining of materials that changes how they're bonded together. Does that make sense? So it worked. It worked, right? I started off with 2 of these H2s and 1 of these O2s, and I got 2 H2Os. Does that make sense? All right. So now, here's another one I'm going to give to you, and you're going to help me figure out how to balance it. Okay? See if you can talk to your neighbors to learn together. That's an effective way sometimes. All right, there it is. I need to know what numbers go in front of all of these to make this equation balanced.
H3.
You know how to do it, Whitey? Can you figure it out? No? How many ends are on the left? How many ends are on the right? So what do you need on the right? 2. And then how many H's are on the right if there's a 2 there?
I think about the H.
Okay, so then how many H's are there on the right if you put a 2 in front?
And a way to help you think
6,
of it
so
better
how
in
many
your
do you need on the
mind
left?
is to
Got
identify
it?
all
Okay.
the different kinds of atoms that are on the right
Sam
side
can talk to you.
and the left side. Start with the numbers that you have. How many do you have of these? 2. How many do we have of these? 2. How many do we have of these? 1. And how many do we have of these? 3. Does everybody see how we only have 1 nitrogen to start off with? Can you see that? Everybody sees that we have 3 hydrogens. Okay? All right, so what do we got to do? We need more what? What do we need more of on the...
You need more H.
More H on the which side?
Right. Left side.
Left side, and more H over here. Does everybody agree with that? Can you see that, Tom?
Yeah, 3 more H. And less more H.
No, 1 more H.
3 more H. 3.
Oh, 1 more, yeah.
3 numbers.
So I'm going to put what? 3 here?
Yeah, 3.
Yes.
That will give me
And then put
6,
3 on
right?
the right.
Do you guys agree? Is that going to give me 6 hydrogens if I put a 3 here?
Yes.
No?
Yeah, it will because 3 twos.
3 of these
times 2.
H2s,
Oh.
right?
3 times
All right, where
2.
you going,
Good
Emma?
job.
6.
Oh.
And
Okay.
And put
And
1
the
for
other 2.
and 2.
And then on the right.
On the right side, you need to put 2.
2 of these.
Yes.
Yeah.
That'll give me 2 nitrogens and
6.
6 oxygen, or 6 hydrogens.
Because then there's 2.
Is that correct?
Which
Yeah,
is
but-
there too.
So then, what about the first one?
Right.
It doesn't need to.
Looks like that number has to be a 1, right? All right, very good. So we balanced another chemical reaction, right?
Dan, 1 minute.
Balanced it. Does that
Dan.
make sense?
I don't get it.
What? Who doesn't get it?
Me, I don't get it.
Oh, you need to pay a little more attention. How many nitrogens do we have on the left side here right now? One, come up here and point them to me.
You have a waste.
Thank you. Hustle up, hurry. Point to all the nitrogens. No, right here or in down here, because that says 2, right? So, can you see that we have 2 there? Oh, okay, so we have 2. See, N, 2, so that means there's 2 nitrogens, right? How many hydrogens do we have on this side? 6. Very good. How many hydrogens do we have over here? Are you sure?
Wait. 5.
Can you identify where they are? Where are they?
What's supposed
Point to them in the equation.
A lot of times.
Cause,
Uh-huh. There's
oh, yeah, right
3 hydrogens here. but there's two of these things. Correct. All right, so does that make sense? All right, good.
If it was plus,
Good
Okay,
job.
so,
you have a eraser.
well, I like both erasers, though. I want to give them both some time. All right, how much time left?
Time now.
Okay, great. So you learned a little bit how to balance equations. Tomorrow we'll try a little bit more on balancing equations.
You
okay?
told them you were going to talk about moles.
Yeah, next time.